I want to do a quick video on converting back and forth between rectangular and polar coordinates. I would urge you to not always want to go into rectangulars. It's kind of the comfort zone, but I would urge you, if something's given to you in polar coordinates, it's probably for a reason. But there's there's some good math here to think about. I'm going to pick a point. Let's call that 3 and pi over 6. I'm going to pick that point, and I'm going to convert that to rectangular coordinates, meaning in x and y. Now, it's actually a pretty easy process. If you think about a triangle, we want to know what x and y is. We're going to just make a little right triangle. Of course, this is x, this is y, and we know the hypotenuse is 3, and we also know the angle. So, of course, just using some simple trig, we can calculate x and y. If you do that, you find out that x is always equal to the radius, or that in our case 3, multiplied by cosine of theta, and y is always equal to r multiplied by sine of theta. Now, this is an absolute key to remember through everything you do with polar coordinates. X is equal to r cosine theta, y is equal to r sine theta. Don't forget that. It really plays a huge role in finding derivatives later. So in our case, x is equal to 3 multiplied by the cosine pi over 6, and y is equal to 3 multiplied by the sine of pi over 6. Well, using the hand trick, or however you choose to remember it, this becomes 3 multiplied by the square root of 3 over 2. This one becomes 3 multiplied by 1/2. So our final coordinate is 3 square roots of 3 over 2 and 1/2. And it's always that way. It's just always r multiplied by cosine theta, and y is equal to r multiplied by sine theta. Now, less likely probably in your work will be converting to polar coordinates from rectangular, but I thought it would be a good thing to think about, and it gives us a good conversion. I'm going to pick the point 3, 3. Okay, so the point is 3, 3. And again, we're going to rely on right triangle trigonometry. You can kind of see that, we've got we want to know what r is, but we already know what x and y are. They're 3. We want to know what the angle is. We're just going to use trig. So r squared, using Pythagorean theorem, is equal to 3 squared plus 3 squared. So that means that r is equal to the square root of 18, or 3 square roots of 2. That's r. Now, the angle, of course, we know the opposite and adjacent, so we're talking about tangent, but we're looking for the angle, so we'll use inverse tangent, in this case of opposite over adjacent. So the inverse tangent of 1 will be equal to theta, so theta will be equal to pi over 4. So our point in polar coordinates will be 3 square roots of 2 and pi over 4. So the conversion factor really is just always, you're going to start by doing Pythagorean theorem with x and y. X squared plus y squared equals r squared. And the other one will be saying that theta is equal to the inverse tangent of y divided by x. And that's it. That's how you get those two. So it's just formulas, just plug right in. Finally, we can use those things that we've learned to just convert formulas and figure out what kinds of shapes they are if they're in polar coordinates or in rectangular coordinates. So I guess the things you've got to remember to do this is x is equal to r cosine theta, y is equal to r sine theta, and that x squared plus y squared is equal to r squared. And some of these are a little bit harder, and some of them are actually very easy. So I look down at this very first one, and I think, boy, if only there were an r here, that would really be nice. Well, why not make put an r there. Why not multiply the entire thing by r? So r multiplied by r is r squared, and I have 4r sine theta. Well, I know what r squared is. It's x squared plus y squared. I know what r sine theta is. It's y. So I have x squared plus y squared minus 4y equals 0. This is just a circle. You could do some completing the square, but this will just be a circle. Over here, the second one is actually a little bit easier. It's usually easier to go to polar than it is to go to rectangular, because all I want to do is replace the x and y and get down to sines and thetas and r. So I'm just going to replace each one. So x will become r cosine theta. Y will become r sine theta. And I could clean this up a little bit and have 4r squared cosine theta sine theta equals 9. And that's really as much as you have to do. It really is all about using these three things up here. That's because those are really the only tools you have to convert.